Hi, good morning, everyone. Thank you for being on time. We're going to go ahead and get started. So last class, we were talking about the process of science, right? And within the process of science, there are two kind of major approaches to doing it. The first one is discovery science, and then the other one is hypothesis driven science. And we only had time to talk about discovery science, but let me just quickly refresh your memory on what that is. Discovery science. Okay, so discovery science involves making observations, right? Without changing the system. You're just watching, you are an observer, you are a bystander, you're not changing anything that you're looking at, okay? And these observations, they could be qualitative, using our senses, or quantitative, using measurements. And you're gonna record all your observations. Right. Now, in class, right, I try to make it simple for you. That's why I say things like the fly is made out of cell, the tree is made out of cell, the mushroom is made out of cells. Like all the sentences are the same, but like in reality, right? Like they don't have to be about the same thing, right? So let's say you are observing how monkeys behave or something. Okay, so like your observation, you're watching them for like a couple weeks at the zoo or something, and you can say, oh, the monkeys like to be together, right, when there is food around. Okay, and then another observation would be like, they are never really by themselves. They always hang around with another monkey. Okay, you will always see at least two of them together. Yeah, and then another observation would be like, sometimes they like to huddle together, okay, and just do frog legging or something. Okay, so like all these things are not the same kind of observation, but they are related to each other because you're observing the monkey. So your conclusion based on those observations would be monkeys don't like to be alone. Okay, they like to spend time together. Right? So like it doesn't have to be the exact same sentence structure. I just presented that way so that it was easier for you to understand. Okay, but as long as the observations are related to certain concepts, and then you apply it, you put them all together and create a general statement. That is the process of inductive reasoning. Okay, so some of you, not a lot of you actually, some of you tried the online practice quiz already. And there was a question about inductive reasoning, right? So if you haven't already, take a look. And using what I just told you, maybe it will make more sense to you. Don't worry too much, okay? There's only like one or two questions about inductive reasoning and deductive reasoning on the quiz, right? But it's a good thing to understand. So that you're gonna come up with a general statement. General statement that might or might not be true. Okay, might or might not be true. And then you are gonna apply this to like different scenarios, right? Okay, so this first part here, that is induction, inductive reasoning, and then the other half, that is the deductive reasoning, right? Deduction. So this general statement may or may not be correct, right? You are just coming up with a trend that you have observed, and then you don't know if it's true or not, right? And that's where the next part comes in, right? We're gonna use the scientific method to test that general statement, right? To run experiments to see if it's actually correct or not. Okay, and that is what we call like hypothesis-driven science, the second part, right? Let me just quickly refresh your memory of what we are talking about here. There, right? So discovery science is what I just described to you, and now you want to test that general statement. We're gonna switch gear to hypothesis-driven science. And to do hypothesis-driven science, we use the scientific method. Okay, so there are different steps in the scientific method, making observations, which is similar to discovery science. Okay, there's some overlaps. You know, having a question about what you're observing, coming up with a hypothesis, predicting the results, experimenting, and concluding. So we're going to look at each one of these in more details in the upcoming slides. Let's start off with a very simple example to just kind of help us understand what's going on. Let's say you had a long day, you go home and you want to watch some TV. So you sit down, you pick up your remote, you press on the remote, nothing happens. That's an observation, right? The remote doesn't work. So logically, you would think, what's wrong? Right? Something's wrong. Right? You might press a couple more times, still not working. What's wrong? That's the question that arises from what you're observing. Then you have some ideas of what could be the problem, okay? Based on maybe previous experience that you've had, or like you're just guessing what's wrong. Right? So the most common problem is that the batteries are dead. Right? So you make a prediction. If I'm correct, that means I need to replace the battery, and then it should work. So you go ahead and you replace the battery. That's the experimenting part. That's like, trying to see if your prediction, if your hypothesis was correct. So you replace the batteries, one of two things could happen. It either continues to not work or it works. So if it works, then your experiment supports the hypothesis and then you're done. Otherwise, you will have to revise your hypothesis. Okay, so like maybe it wasn't it's not the battery. Okay, maybe the TV was unplugged. Okay, and so that flow of logic is basically a simplified version of the scientific method. Okay. Now, I am going to use a few scenarios here to help us kind of understand the process of the scientific method. You should try to understand as much of this as possible. I mean, like as with everything, right? But particularly important for this lesson, because what you learn here in this lesson today is going to help you tremendously with your lab, okay? Your first lab. First lab has to do with the scientific process. So you have to understand, what it is, how to write hypotheses, identify different variables, and understanding the meaning of different aspects of an experiment. Okay, so I'll try to go slow. If you have questions, please just pop them in the chat box, or just raise hand in the Zoom, and then you can talk to me directly. That's probably the best way. All right. So I want to present to you this situation. You've noticed some plants grow taller than others, even though they're the same kind of plants. Okay, some grows taller than others. All right. So like you might wonder why. Okay, why that is the case. So the observation is that some plant grows taller than others. The question is, why do they have different heights, even though they're the same plant? Right? Shouldn't they, have the same height? Okay. So to find the answer to our question, or sometimes you have more than one questions, then we use the hypothesis-driven science. So observation, question, the next step is hypothesis. Right? Hypothesis is a tentative answer. And some people like to call it an educated guess. Okay? I don't really like that. It's not really a guess. Okay, like your hypothesis should be based on some knowledge that you had before. Okay, should be based on some facts that you already have. Okay? You try to come up with a possible answer to your question. So help me out here, guys. The question was, why do the plants have different heights? So what might be a hypothesis for that? Yeah, you can type it in the chat box. I'll give you a, maybe a minute to do that, or you can just unmute and tell me about it. What would be a possible explanation for that? Okay, so Zainab say the type of fertilizer used. It could be, right? That's a possibility. Justin say plant genetics, possibly, but we are using the same kind of plants. So you're saying maybe one plant has poor genes or something. Could be. Maybe one plant is not getting enough sunlight. Okay, excellent, right? So all of these are great possible answers, right? Okay. Now, that is how you would come up with a hypothesis. Now, the hypothesis that you come up with is valid if it is testable and falsifiable. Testable means you can test it. You can run an experiment to check to see if it's correct or not. Okay? And all the suggestions you guys made can be tested. Okay? For example, someone said fertilizer. Okay, so I could give one plant fertilizers and the other not fertilizer, and then see if there's a difference. I can test that out, no problem. The other criteria for a valid hypothesis is that it must be falsifiable. What does falsifiable mean?
It could be wrong.
Yeah, Ramon said it could be wrong. Exactly, right? So like you can't have you can't have an answer that's always correct. If that's the case, then you already know the answer. Like, what's the point of doing the experiment, right? So things like opinions, cultural, religious beliefs, superstitions, myth, values, moral judgment, and supernatural stuff, these are not testable. Okay, and sometimes it's not falsifiable as well. So we want to leave those out of the hypothesis. Let me give you some example of invalid hypothesis. Animal testing is bad. Okay, so that is an opinion. You might think it's bad, someone else might think it's okay, and you could both be right. Okay, there's no way to test it. It's a personal opinion. It's a personal, moral compass, right? You cannot test that. Rock music are better than classical music. That is another opinion. You cannot test that. So not testable. Therefore, it's invalid. Next one. The garden fairies made some plants taller taller than others. This is supernatural things, right? And it's not testable, but it's also not falsifiable, right? A person can say, it is the garden fairies, and then someone else says there are no garden fairies, and then the first person could reply and say, how do you know there are no garden fairies? Because I haven't seen one. Just because you haven't seen it doesn't mean they don't exist, right? Okay, maybe they're hiding. You cannot find them, right? So there's no winning the argument, right? Like, and it's a reasonable argument, right? Just because you haven't seen it, just because you haven't seen something, it doesn't mean it doesn't exist, right? Like, for example, I've never seen a live dinosaur. Okay, does that mean they don't exist? Like, I think all the fossils are not real. Like, people just make them up, and it's all fake. Okay, there are no dinosaurs because I haven't seen one, right? So like that that might sound like a not a very smart argument, but it's the same kind of thing, right? When you apply to superstitions, right? Like people say there are no ghosts because I haven't seen one, right? So these things you cannot be wrong. You cannot prove them wrong, so to speak, right? And therefore, it's not falsifiable. Therefore, it's an invalid hypothesis. Okay. Everything that occurs is as a result of divine intervention. that is also an example of superstitious thinking, or supernatural religious belief, right? We cannot prove them wrong, and therefore not testable as well. So these are examples of invalid hypotheses. Valid ones, right? So back to our example, right? Plants receive more sunlight, grows taller. We can test this, right? We could be wrong. Driving with the windows down will increase fuel consumption. Do you guys know this is like a big debate for a lot of people, right? Some people think driving with the windows down will save fuel because you are not turning on your AC or your heat. Other people think that if you leave your windows down, then there is too much drag on the car, right? It's not very aerodynamic, right? Okay, so Justin said it's true. Which one is true? Like driving with the windows down is better? Yeah. um, okay, yeah. And then we have Justine who said it's true because of aerodynamic, right? So like, people have their different opinions, but you see, even though people have different opinions, we can actually test this. Okay, I mean, you can test it, right? You can drive your car, for a week with windows open and then with windows closed along like similar routes, right? And then you can check to see your fuel consumptions. But there are other factors that we have to consider as well, right? We're going to come back to this concept later. All right. Next one. Taking melatonin will increase sleep duration. Do you guys know what melatonin is?
Yes.
What's melatonin? Educate me.
The thing in the brain that makes you sleep.
That's right, the thing in the brain that makes you sleep. You have a part of the brain called the pineal gland. It secretes melatonin. It's a hormone, and you will go to sleep when you have a certain level of melatonin. But you can actually buy them as pills as well. Okay,
Yes.
so people take the pills, and then some people swear by it. It's like, oh, taking the melatonin um, give me great sleep. But there are also studies out there that says it's mostly placebo. Okay. Um, Again, something that we can test and something that could potentially be wrong. So these are
Yeah.
valid hypotheses.
For
Okay.
example, for me,
Mhm.
it doesn't work because I already have the good the hormones.
Right.
If I take it, it's not gonna work. So
Yeah. So like it's a divided
yeah.
situation, right? Thank you. Um, so yeah. The point is, we can test it. Right? We can have a group of people who take melatonin, a group of people who don't take it. And then later on, you will see that we can have people who take placebos as well. And that's all about setting up an experiment and then testing the hypothesis. Okay, very good. Next part comes to designing the actual experiment. Okay, and some people have a lot of trouble with this concept of the different kinds of variables. So please take out a piece of paper. We're going to take some notes, right? But let's just set the stage. Right? We were using the scenario with some plants are taller than the others, and then we have an hypothesis. Okay, let's just use this one. Plants receive more sunlight, grows taller. We are now going to test that to see if it's true or not. Now, people mention a lot of other things, right? You guys were saying about like fertilizer, amount of water, where you put them, right? The temperature and so on and so forth. So all these factors can be different, right? All these factors can be changed. We call these variables, okay? Variables. Now, when you do an experiment, you want to limit the number of variables. You don't want to have, 5, 6 different things that are changing. Because if you do the experiment and you see that at the end one plant is taller than the other, I cannot pinpoint exactly which of these variables is responsible for the difference, right? Okay, maybe multiple variables have an effect of the height, right? So if you want to just test sunlight as a possible reason for the difference in height, then you need to keep everything else unchanged. okay? We need to standardize the condition, all right, for everything else except for sunlight, okay? So the two things that we don't standardize in an experiment is what we call the dependent variable as well as the independent variable. So let's take a short note on that and make sure that we have a good understanding, and please make sure that you do, because when we do the lab, right, like you want to be able to identify what these variables are. So independent variable. Okay, I'll try to write as nice as possible, but if you can't read my writing, just let me know. It's not a problem. So independent variable is the variable that is being altered in an experiment. Okay. One way to remember is independent variable is the variable that you are in control of. Okay. You, as in like the person who's doing the experiment, right? You deliberately choose to change this variable. Now, in our case, the independent variable would be the amount of sunlight. Amount of sunlight. Okay. You can change that. You can put the plant with a lot of sunlight. You can put it in the shade, right? You can move them around. That would change the amount of sunlight. So that's the independent variable, the one that is being changed. The dependent variable, that would be the variable that is being measured or observed. Okay. What would that be in the case of our experiment? What is being observed?
The growth of the plant.
The growth of the plant, right? And more specifically, what aspect are we looking at about to assess the growth of the plant?
The height.
The height, that's right. Okay, so in this case, it will be the height of the plant. All right, that's it. So what is the goal of the experiment? The goal of an experiment is to determine if changes in the independent variable has any effect on the dependent variable. Okay, in this case, does changing the amount of sunlight have any effect on the height of the plant? Okay, that's independent variable and dependent variable. Everything else should be standardized. Everything else should be kept the same. Okay, I'll give you guys a moment to copy, and if you have any question, please ask. Okay. So once we figure out what our dependent and independent variables are, we can go ahead with the experiment, right? One plant can have 6 hours of light exposure per day. The other can have 12 hours of light exposure, right? But in addition, we have to make sure everything else stays the same, right? So those are what we call standardized variables. Right? So here are some examples, right? You want to have the same type of plants, okay, naturally. You want to have same initial plant height, right? So they start the same, and then afterwards, you can see which one grows more, right? Soil type, people mentioned that already, right? You don't want to have one that's like super fertilized and the other is not, right? Amount of water, type of light exposure. What I mean by that is, sometimes it's hard to control sunlight because like what if like the cloud comes in or something, right? So like for the purpose of standardizing things, maybe you want to use one of those indoor lights for the plants, right? Okay, those greenhouse lights. Humidity is another one. Temperature is another one. So all these things you want to keep the same. And the reason is, okay, and you should write this down. Okay, the purpose of standardized variables is to ensure any observable difference in the dependent variable is caused by changes in the independent variable. Okay? Write that down first, and then I will explain further. Okay? Everything else are kept the same so that if you see a difference in the dependent variable, if you see a difference in the height of the plants, right? You know that is because of the sunlight, the independent variable. It's not because of any of these, because everything else was kept the same. Right? It has to be the only thing that you change. Does that make sense? It's hard online because like I can't see your faces, and then like usually I can read the room and see if people are really lost, right? Or if they really get it. But I mean, if you get it, right? Give me like a thumbs up or something as an icon, right? Or if you have questions, right? Give me a thumbs down, and then I can explain further. Okay, great. Now let's go back a little bit here. Now let's take a look at the other two scenarios. Okay, like driving with the windows down and fuel consumption. What would be the independent variable in this case? If I wanted to test this, oh my goodness, if I wanted to test this, right, what would be the independent variable?
Open the window.
Yeah, the state of the window, right? Driving with the windows down or driving with the windows up, right? So independent would be the state of the windows, opened or closed, right? And what are you trying to assess? What are you trying to assess in this case?
Fuel.
That's right, fuel consumption. How much did you use, right? Fuel consumption, Right? So those are the two things. Let's talk about standardized variables. In order for us to test this hypothesis, okay, we need to keep everything else the same. Right? So, Madison earlier mentioned about driving routes. That would be a standardized variable. That's not something you want to change. Right? You want to take the same route every time, right? Make sure that it has the same up and downs, right? Same distance. That way, if at the end, right, there's a difference in fuel consumption, it was caused by the state of the window. Sorry, someone was saying something?
Use the same type of gas.
Yep, same car, not just the same type, just drive the same car, right? Okay, like you wouldn't want to drive different, like a Toyota on one day and a Corolla. Sorry, they're the same thing. I mean, like a Corolla on one day and a Civic on the other day, right? Like they are the same type of car, as in they are both sedan, but they are not the same car, right? So you want to keep the same car. Other people say same
Gas.
speed, yeah, same
Type of
speed,
gas.
same type of gas. That's right. So all these things have to be standardized, right? You want to have the same driver, same amount of people and stuff in your car, so the weight is not different, right? So you try to keep everything as constant as possible. Is that okay?
Mm-hmm.
Hey, what about the next one? Okay, let's do a poll. Let's do a poll. So that I kind of know where you guys are at. We have two things here. We have taking melatonin and we have sleep duration. Okay.
Mm-hmm.
Which one is the independent? Okay, choose A if you think taking melatonin or not is the independent variable. And then if you think this amount of sleep, the sleep duration is the independent variable, please choose B. I'm looking for the independent variable here. Which one are you in control of?
Oh, control.
Okay, a lot of people answered. Thank you. So this is the class result. Now, most of you got it right. The correct answer is taking melatonin. Okay, remember, independent variable is the one that you can change. You can't change how much you sleep, okay? But you can control whether to take the melatonin or not, right? Okay. So if you're gonna do an experiment, right, you're gonna have people who are taking it, and you're gonna have people not taking it. All right. And the standardized variable in this case is a little bit complicated, so we'll come back to it later. But for now, that is that. Okay. I have a quick activity for you guys to do. In your study guide, second page, there are 4 questions here. Okay. I hope you have the study guide. If not, I leave it here for a second. You can take a picture of it, take a screenshot. I am going to put you into groups, and then you guys can work on it for like, a couple minutes, for 5, 6 minutes, okay? And then we're gonna come back together, all right? So I will put you into random groups. You will join the groups. You will please discuss the questions together, okay? The person in the group that has the like in alphabetical order, okay, the ones that closest to A, that's going to be the group leader, okay? You're going to be leading the conversation, okay? And then you guys can work on it and record the answers, and then we're going to come back together afterwards, okay? So you guys can get to know each other a little bit. I mean, like, we don't really physically see each other, but we can still learn to work together, and yeah. So here we go.
How do we get into groups? Like, how's that supposed to work?
Okay? So like, I'm gonna press the button now, and then you will see an invite, and then you just press
Okay.
join, and then you're gonna go there. Okay, and then there will be a warning later on that says, okay, the room will close in a minute, and then you just have to come back, and then we'll be together again. Okay, let's try this thing. All right, here we go. All right, welcome back, everyone. I saw that a lot of you had some good discussion. Like, I mean, I don't know what you were talking about, but then I see the mic icon like moving for like everyone in the group. So I assume you guys were having a good conversation and a good discussion, hopefully. And let's take it up. All right. First question. In students watched a cartoon either alone or with others, then rate how funny they found the cartoon to be. Now, I'm just gonna save some time. I don't want to write it all out. I'll post the a solution later on online. Okay, but like for the purpose of saving time right now, I'm just gonna highlight it. Okay, so the independent variable in this case would be whether they watch the cartoon by themselves or with others, right? Okay, and then the dependent variable, that would be rating how funny the cartoon is. Okay. Next one, a comprehension test was oh, I just saw the just saw the message. Yeah, it wasn't enough time. Okay, sorry. Next time I'll give you guys more time for discussion. All right. In a comprehension test was given to students after they had studied textbook material either in silence or with the television on. Okay, so that is the independent variable, right? And the dependent variable is not really explicitly written here. Does anybody want to help me out? What did you guys conclude?
The grade on the test?
Exactly, right? That would be the grade on the test. Grade on comprehension test. Okay, grade on test. Done. Next one. Some elementary school teachers were told that a child's parent were college graduates, and other teachers were told that the child's parents had not finished high school. They then rated the child's academic potential. So the independent variable, again, it's not really explicitly stated here. Does anyone want to tell me?
Dependent variable.
I'm sorry, one more time, please.
Dependent variable.
Yeah, what is the independent variable? Yeah.
Oh, if the school teacher was told if a child's parents were college graduates or if they were not, or if they have not finished high school.
Yeah, exactly, right? So like basically, parents
Education.
education, exactly, right? Parents education, like whether it was made aware to the teacher or not, right? Right. So parents education info given to teacher or not, right? Dependent variable would be the child's academic potential. Okay. Last one. Students at a university were split into two groups and each receive a different text for a philosophy course. One group received a traditional textbook while the other received interactive textbook. That would be the independent variable, right? The kind of textbook they are using, and afterwards it would be the final exam marks. Okay. Hopefully you have a better understanding of what independent variables and dependent variables are. I got a private message. If this was a test and we put just parents' education, would we lose marks? Probably like, be more specific, right? Might be more specific because like you can't really control the parents' education, right? Like it already happened, right? What we're really testing is like, does the teacher's knowledge of the parents' education have an effect on how they evaluate the child's potential, right? Okay, so I would be a little bit more specific. I hope that answers your question. Okay, let's move on. If there are no other questions. You know, I actually did a experiment. You know, when we returned from the pandemic, right? We had the online class and then the in-person class, right? Like I try to keep everything as consistent as possible, and then I wanted to see, right, whether people do better online or whether they do better in person. And I gotta say the result were surprising. Okay, let's go back to our PowerPoint here. All right, so back to our planned situation. All right, we keep everything else the same. We're gonna only change the sunlight. We're gonna make a prediction, right? What do you expect to happen if the hypothesis is correct? What do you expect to happen if the hypothesis is incorrect? Okay, so if the hypothesis is correct, then the plant that is exposed to more sunlight will be taller. If the hypothesis is incorrect, then either the height would be the same or similar at least, or more sunlight will actually make the plant shorter. Okay? So we have our expected results. So you go ahead and you do the experiment. Okay, you do it for like, I don't know, like 2 weeks or something, 1 week, 2 weeks. Right, and then you take a look at the difference. Right, the height is 12 at the beginning, and then it only grew 1 centimeter if they get 6 hours, but it grew 6 centimeter when it was receiving twice as much sunlight. Right, so based on this hypothetical result, we can conclude that our hypothesis was correct. Okay, and you know, more sunlight allows it to grow taller. But this is very like oversimplified, right? Like you can't make a conclusion based on a single experiment, okay? Based on, you know, just having 2 plants side by side and then make a judgment call, right? Like in real life, you have to have a large sample size, and you know, you have to do some statistics, some math to really figure out, you know, whether or not there is some kind of relationship between the dependent variable and the independent variable, right? But this is just like a simplification to introduce you to the idea.
I have a question.
Yes, please go ahead.
So does it matter about the amount of people used for the experiment?
Yes, it does. And we're gonna come back to it. You asked great question, and I feel bad. Every time you ask me something, I think last time you also asked me something, and I said we'll come back to it, right? But we will, okay? Couple of slides later, we're gonna talk about experimenting that involves humans. And in those cases, right, we want to consider the sample size, right? You don't want to just have 10 people. That's too small of a sample, right? Like when people test vaccines, you literally have to test thousands and thousands of people, right? So,
Yeah.
you know, that's definitely going to be a factor.
Okay.
And once you've come up with a conclusion, usually it leads to more questions, right? So in this case, maybe we want to find out the optimal amount of sunlight, right? So like, you know, 12 hours gave the plant taller, maybe 18 hours will grow even taller. Like what's the optimal exposure? Okay, is 24 hours like continuous amount of sunlight the best? Maybe, maybe not. Okay, maybe we'll fry the plant, right? Because you don't know. So you have to do another experiment to figure it out. And that's the same thing for real life, right? Situation. Once you figure out the vaccine works, you have to figure out the optimal dose. Do you just give them 1 shot? Do you give them like, you know, multiple shots, you know, throughout the year, right? Like a booster shot, right? How much do you give? Do you give the same to kids? Do you give this as you give to adults? So many different questions. But in an experiment, you can only test one thing at a time, right? If you change too many things, then you don't know what's causing the observable difference in the dependent variable, right? Okay, everything must be standardized except for the independent variable so that you can see how it affects, if it affects the dependent variable. Okay. Hold on. Let's do a quick poll question here. Which of the following steps in the scientific method involves producing a tentative answer? Okay, maybe just a couple more seconds. Please pick something if you haven't already. Okay, the correct answer is hypothesis. Okay, we wrote this down earlier, right, in the slide. A hypothesis is a tentative answer to your question, right? It's a possible explanation, possible answer for the question that you are asking. Okay, so the answer is B, okay, hypothesis. Here's another one. Okay, just a couple more seconds. Oh, that's okay, Kiana. I was wondering who pressed F. No worries. Just don't do that on the test, okay? All right, let's end the poll. Okay. Half of you got it right. I guess that's could be better, I guess. A set of actions or observations designed to test specific hypothesis. How do we test the hypothesis? How do you know if your prediction is correct? You do an experiment, right? You do an experiment, guys. Right? Yeah, the keyword is test. That's right, right? You need to run the actual experiment to know if you're correct, right? To know whether sunlight affects the height or not, you need to do the experiment, right? You need to put some plants in sunlight, some not, and then compare the difference, right? So that is the answer. Okay, so just to recap very quickly, hypothesis, that's the tentative answer. Tentative answer. Observations. Okay, observations, I guess, is a little bit tricky, okay? Because you make observation, that's like the first step, right? In the process, right? You see things, you notice things. That's observation. But you're also observing when you're doing your experiment, right? Okay, so that's like has like dual meaning in this case. Data is like the measurements that you collect, right, from your experiment. And then the prediction is, you know, after you come up with your hypothesis, after you set up your experiment, you predict what's going to happen. You know, if my hypothesis is correct, I should expect this, this, this. If I'm wrong, that should happen. All right. So that is the the situation here, guys. Why don't we take a 5-minute break? It's 9:26 right now, so we'll come back at 9:31, and then we will do more. If you have questions, you can leave them in the chat box, and I'll be sure to address them. Okay, so have a break, 5-minute break, guys. See you in a bit. Hello, it's me again. Let's keep going. So by now we learn the discovery science. We learn about hypothesis-driven science. You might wonder who came up with this stuff, right? Like who's the person who came up with the scientific method, right? So a little bit of history, and it will serve also as another example of how this process actually works. Okay, so there's something called spontaneous generation. I don't know if you heard about it, but for as long as a human existed, we probably, one of the biggest question we have is, where do we come from, right? Okay, like where do life came from, right? So in the mid to late 19th century, there was this theory around called spontaneous generation. Okay, so people observe that if you leave a piece of meat outside and let it be, a couple days later, you will see maggots and flies on it, right? So people are saying, hey, the meat is not alive, and then you have all these living things that are spawning from it. That must be how life originates. Okay, the idea of living matter arises from non-living things. That's the theory of spontaneous generation. Okay, you look at that right now, and you're probably thinking, hey, like obviously that's not true. But remember, right? That's a long time ago, right? People didn't know what we know now. I'm sure, 100 years later, when they look back, they're like, how did they not know that, right? Like, as we advance, we expand our knowledge, right? But that was the main theory, right? In the mid to late 19th centuries, and there are support for this concept. People see things raining from the sky, like fish and frogs rain from the sky. And that is something that actually still happens today. Like I just did a quick Google search for on Google News, and then I found these headlines, right? Like Texas witnesses a rare weather phenomena as fish rain from the sky, right? Fish fall from sky with rain in northern Mexico, and so on and so forth, right? So these are things that actually do happen, right? And again, in the past, people saw those things happening. They were like, see, right? Spontaneous generation, the fish, it's like literally raining from the sky. Maybe the gods is, providing for us through this process, right? The worst I've seen is spider rain. Really, I have thank goodness I've never experienced that before, but that sounds like something straight out of the horror movie. But anyway, does anybody know why this happens? Why do fish rain from the sky? What's going on here? Anybody heard of that before? Have an explanation for it? It does happen. I've never seen it like in person, but I've read about it. What's the reason?
From what I'm reading here, it says tornadic water spouts.
Oh, from what you read, so you just Googled it like at this.
I honestly have no idea why it happened.
Excellent. Okay, see that's how a class should be, right? Like you guys can find information right away, right? Like what does ChatGPT say? But that's right. Tornadic water spout, right? So sometimes like a big like a tornado, right? Basically sweep through over a lake or river, and then they scoop up all these aquatic lives, right, including fish and sometimes frogs and other stuff. And then the force of the tornado is so strong that it sent them flying miles inland, right? And then they rain down from the sky. And that's basically what's happening. But people didn't know that back then, right? They didn't have a good understanding of, all these natural phenomena. And then they use that as a support for spontaneous generation. Okay, so that's the background story that you have to know. One person in the 1600s, his name was Francesco Redi, right? He didn't think that spontaneous generation is how life arises. Okay, he didn't believe that, and he wants to come up with a way to disprove that. Okay, or at least to show that it is not true, right? So here it goes. Right? First, we begin with observation, right? Observation is flies and maggots can be seen around pieces of meat left out on the counter. Right? That was the observation people are making. That's the argument people are saying, how life originates from non-living things. The question, where do flies come from? Is the rotting meat transformed into flies? That's a valid question, right? So, hypothesis. Francesco Redi, he hypothesized, he tried to answer his own question, right? That's the next step, right? A tentative answer. He thought only flies can make flies. Rotting meat cannot be transformed into flies. All right. So let's take a look, take a note here. Where were we? Okay, right here. And we're going to talk about Redi's experiment. Okay, he wants to know if meats can be transformed into flies, basically. So this is what he did. Right? He had 3 containers. Okay, please draw along. All right, like if you have not heard this before, it's first time you're hearing about it, draw along. There will be a question about this on the quiz. Okay, so he had 3 jars. These are jars. Okay, he put a piece of meat in them. Okay, meat, and then meat. Okay. So in the first setup here, there is no cover, no lid, and no covers. It's just open to the air. Next one, he has a netting. Okay, a netted cover. And then the last one, he sealed it with some kind of cloth. I guess they didn't have saran wrap back then. I assume he sealed it with some kind of cloth. Okay, so this is a sealed jar. Okay. He then left these jars outside for, I don't know, like 1 week or something. And then afterwards, he wanted to see whether the flies and the maggots will be there. So in this experiment, what is the independent variable? What is the independent variable? What was he in control of? Very good. Okay, a couple of people say the right thing, and then there are a few other ones that are not quite correct, but that's okay. Right? The independent variable is the type of coverage, right? The type of cover. Like, is it no cover? Is it like netted cover? Is it, seal jar, right? And then we have the dependent variable. What is he trying to measure? What is he trying to assess? How many flies came up? The flies, that's right, the presence, right? The absence or presence of flies. Presence of flies. That's it. Okay. He wanted to see, right, whether there are flies or not. What about standardized? Standardized variable. What must be kept the same? Right? The meat, that's right, the type of meat, right? Type of meat, size of meat, the age of the meat, right? Like you don't want to use a piece that's already rotting, right? Probably like you want to, I don't know, cut them from the same thing, okay? That you just got from the market or something. I don't know where they got the meats from back in the days, probably from the market, okay? What else? Type of jars, yeah. Same size, clean them, right? Clean. Okay. Anything else? Couple of same environment, that's right. Same environment. Don't leave some on the counter and then leave some next to the dumpsters, right? They put them in the same place. 2 more, please.
Same weather.
That's right, right? But yeah, I mean, logically speaking, if you leave them in the same place, they would experience the same weather, right? Yep, same temperature, good. I was thinking about duration, right? Leave them all out for the same amount of time, right? Everything stay out for 1 week, everything stay out for 5 days, right? That's another one, okay? So I think
Same
that's good.
time.
Same time, yeah, exactly. Same duration, same time. All right. So then afterwards, what's the result? I'm going to tell you the results, okay? The result is probably what you expected, okay? What will you see on this one? Yes, fly or no fly? Yes, fly, right? Okay. Like if you don't believe me, try yourself, okay? It's it's really gross, okay? So there is the maggots, and then there are the flies buzzing around, okay? As expected. Yeah. This one with the netted cover, right? Flies or no flies? Yeah, they have a little bit of flies. Okay, the maggots are on the netting, but they're not like on the meat. Okay, they're just like, you know, buzzing around like that. Okay, not on the meat themselves. And over here, no flies, no meat, right? Exactly what you would expect, right? So then he, based on this experiment, he concluded that flies do not come from meat. Because if they did, you would have seen them in all the meat, right? Okay. So the conclusion is that the theory of spontaneous generation is incorrect. You can reject that. All right, from this experiment alone. So let me see if I have a next slide. Yep. Okay, there we go. After that experiment, you know, he convinced that some people, but there are still people out there who disagree in the scientific community. They're like, okay, fine, maybe flies don't come from the meat, but spontaneous generation can still be true for microorganisms. Okay, so like maybe for like bacteria, right? They could arrive spontaneously from non-living things. Okay? So then another person came along. His name was Louis Pasteur. You might not have heard of him, but if you drink milk or you consume honey, I guess, eat honey, drink honey, then, you know, what's the process that makes them safe for consumption? You can't just drink the milk straight from the cow, right? Like that's not safe, right? Okay, so like what process makes it safe?
Pasteurization.
Exactly, right? Pasteurization. They are pasteurized, right? Guess who invented that process? This guy, okay? Louis Pasteur. His last name is what the process is called, okay? So he came up with another set of experiment to help definitively reject the idea of spontaneous generation. So let's take a look at his experiment. So this is Pasteur's experiment. Now, if you need to watch an animation on this, I have it in the video collection, right? Remember, each lecture has like a video resources associated with it. Okay, so if you want to watch an animation on this to help you understand more, you definitely can do it. Okay, so this is what he did. He had let me draw this a little bit better. He had a flask. Oh boy, flask. Okay, so this is regular flask with regular opening, and then he has another flask with a special neck. This is called a swan neck tube. Looks like the neck of a swan, basically. And what he did is he filled them up with some broth. Okay, I don't know, like chicken broth, beef broth, doesn't matter. Some kind of nutrient broth. Okay, so that's broth. Okay. To help standardize the experiment, what he did first was he boiled the broth before filling it up into the flask, right? And what's the purpose of boiling the broth? And why do we have to boil it before we begin the experiment here? Anybody want to guess?
Sterilize it?
That's right. Right. To boil it first, to kill off any existing microorganism, right? Right. So we know at the beginning, nothing is alive in the broth. We kill them all off. If there were anything that's alive, the heat will kill them off. And then he left these flasks again on the counter probably for like a week or so, and then afterwards he assessed them, right, to see if there are microorganisms. So only the broth that had an open top had microorganisms in them. The other one that has the swan neck, there was no microorganism. Right? So he concluded that it's not the broth that's creating the microorganism. It's probably microorganism in the air that fell into the broth and then they grew. Over here, you might have microorganism in the air, they fall and then they are like all trapped here, right? Like they don't know how to crawl uphill, so to speak, right? So the broth remain sterile. So this experiment definitively showed that spontaneous generation is not true. All right. So what is the independent variable in this case? Independent variable. What was he changing? What was he in control of? The type of opening, that's right. The type of flask, type of opening, type of lid. Very good. And the dependent variable is the presence of microorganism. Right? That's it. I hope you understand that. Any question before I do a poll with you? Great. All right, so here we go. Oh, I guess there's not much point doing it like now, right? Because we literally just talked about it. But whatever, let's do it. Make yourself feel good. Here we go. Okay, the correct answer is the type of flask used, right? The type of flask with either like with a modified opening or not, right? It's not the type of broth. The broth would have to be the same broth, right? That's one of the standardized variables. Presence of microorganism, that would be the dependent variable. Whether the flask was initially boiled or not, again, that's something that he did to ensure the starting conditions were the same, and presence of flies, that's not Louis Pasteur, right? That's Francesco Redi. All right. Now we don't have time to do another group discussion, but on the internet is this thing that has been circulating around. There's a lot of nonsense on the internet, right? But and this is one of the things that people were like debating. The internet claims that watering your plants with microwave water will kill your plants. Okay, and then they even have pictures. They're like, okay, day 1, microwave water plant, purified water plant, they look the same. And then after 9 days, the one that you water with the microwave water does not look so hot anymore. It's like, dying, right? So that's supposed to convince people, say, that's why the microwave is dangerous. Okay, what do you guys think? Do you think this is true? Let's do a poll. Let's do a poll. Do you think watering your plants with microwave water will A, kill your plant, or B, has no effect? What Francis says, can test it on your sister's plant. Yeah, make sure you have her consent though, okay? Oh, by the way, just to clarify, okay? They are not talking about microwave the water for 1 minute and when it's boiling hot and then you pour it in, right? Like, for goodness sake, that will definitely kill the plant, right? This is talking about microwaving it, taking it out, let it cool down to room temperature and then you water with it, right? Do you think that's gonna kill your plant? Okay, very interesting, very interesting. I honestly thought most of you would pick a particular outcome, but looks like you guys are split. Okay, half, almost half. Half of you think it will kill your plant, half of you think it will not. So again, under the video resource, there is a clip that I included that showed someone did an experiment on this. Okay, I will just spoil the result for you. Okay, it does not kill your plant. Okay, microwaving your water does not change the water in any way. Okay, if you leave it to room temperature and then you water your plant, you drink it, okay, you shower with it, okay, it's gonna be safe. It's gonna be all right. Okay, microwave just rotate the water molecule really fast, and by rotating it, it generates heat. That's how it works. Right? Anyway, believe what you will, but that's what the science says. Okay, moving on. We have 20 minutes or so, and we still have like 17 slides. Probably not going to get done, but that's okay. We'll keep going. Next, we're going to talk about experiments that involve human testing. Right? Now, it's complicated when we involve humans, okay? Because there are ethical guidelines that we have to follow, okay? We have to have their consent, okay? We have to have their continuous consent. If someone say they want to stop halfway through the experiment, you got to let them, okay? You can't lock them up in a room and say, you have to stay there until the end of the experiment, right? Voluntary, you cannot coerce them into doing it. You cannot force them into doing it. They have to want to do it themselves, right? They have to be protected from physical and mental harm. Okay, you have to make sure there are measures in place to keep them, from reasonable safety, right? Compensation. Not all testing will involve compensation, but certainly compensation is a motivator for people to participate in an experiment. Some argue, if you're compensating them, then it's not really voluntary, right? Because they're doing something, to have a reward, right, so to speak. So that's that one that is a little bit Depends how you look at it, right? Now, dealing with humans is also complicated because of psychological effects, because of bias. That's just how humans are, right? So for example, like my daughter, when she was younger, like she fell down and then she scraped her knee a little bit. It's not even bleeding, okay? You know, it's like just like a little white spot on it because she fell down on the pavement, and you know, a little bit skin came off, and then she's like, ah, it's like end of the world, right? Like crying, you know, very, very severely. And she's like, it hurts, it hurts, it hurts. And then, you know, we're like, oh, don't worry, okay, we're gonna put a Elsa Band-Aid on, and then almost right away she's like, you know, all good now and go back to playing, right? Did the Band-Aid help her with the situation? Like probably not like physically helped it, right? Okay, it's just like psychologically with the Band-Aid, she feels like, oh, everything is okay now. Okay, Band-Aid is there. I'm protected now. So that's like bias, right? That's like don't look at them, they won't cry. Yeah, they fall. It's like, oh, yep. I don't want to know, right? So you know that's like a psychological effect, right? And that's a real thing for a lot of situations. So when we test a new drugs, we want to make sure the effect is not in the minds, right? We want to make sure the effect actually came from the drug. Okay, so the purpose of a placebo is to minimize bias in results. Okay, so what is a placebo anyway? It's a sham treatment. A sham treatment is basically a substance that has no effect on what you're trying to assess. Okay, some people call it a sugar pill. Right? It's nothing. It's just candy. It's not supposed to cure you from whatever problem you're having, right? So that's a placebo. So in an experiment, right, let's say we want to test a new drugs in treating migraine, okay, you would have the control group. The control group is the group that has no treatment. Okay, you're not doing anything to it. You're not giving them anything, right? So in the previous experiment, right, the control group would be the jar that has no net. Okay, it will be like the flask that is just open on the top. That's the control group. You're not modifying it. Okay, and then you have the treatment group that's receiving the new drug, and then you also have a placebo group, which would be an inert substance. Inert means it has no effect. You know it has no effect. Okay. Sometimes you only need the control group and the placebo. Sorry. Sometimes you only need the placebo group and the treatment group. You don't need a third group with no treatment, because in some cases, you know, giving the inert substance is good enough for control. But sometimes you need to have all three. Okay. No, they don't. What? Can you elaborate that?
Oh no, they were asking if the during medical trials if the placebo group knows that they're taking the placebo, and I know that they know that they don't
okay.
know.
Right.
they're taking
Who's
placebo.
asking that? Oh, someone asking that. Oh, thank you. Okay. Yeah, we're gonna get to that as well. Okay, very good. All right. So does everybody understand what a placebo is? Any questions about that before I talk about this next slide? All right. Now, this is not related to an experiment, okay? This is just an example of how we use placebo in another setting, like in everyday life, all right? So there is this thing called Freya 28. Is a birth control pill that is that women take to prevent ovulation. Okay, ovulation is like, you know, when the egg comes out, right? So if you don't want to have babies, you want to not have the egg released from the ovary to prevent a pregnancy. Okay, so the package is supposed to look like this. You would have 3 rows of the medicine, okay, and then you would have a row, the green pills, a row of placebo. Okay, these pills don't do anything, but you take them anyways. Does anybody want to tell me why they would include a whole row of pills that do nothing in the package? Why are you paying money to buy a row of medicine that does nothing? Yeah, exactly. Okay, a lot of the ladies are like answering, right? To keep track of the time. That's right. So like, you pop your pills for 3 weeks, and then the 4th week you're supposed to be off the pill, but to keep track of time, I would just take one that does nothing. So how come you don't need to take a pill during the 4th week? Like, what happens? Right? Does anybody know why you would need to take it for 3 weeks and then not for the 4th week? Okay, menstruation maybe, period time, allow ovulation. Oh, we don't want to allow ovulation, right? Because like we are talking about birth control, right? So if the purpose is to not want to have pregnancy, then you want to avoid it, right? I mean, you guys are probably on the right track, some of you. We will learn more about this next semester, but basically the pill is progesterone, okay? It's a hormone that your body naturally makes, and then in your cycle, you make them and then it goes away, and then you make them and it goes away. So basically in that particular week, your body will take over and mix the natural amount of progesterone, so you don't have to take the pill, okay? But once that week is over, your body makes less of it, and then you will have to take the pill again. So that's why you need to have the placebo, okay? To keep track of time, right? During the week where your body naturally produces the hormone. All right? That's the concept. So what's the deal here? Well, the company messed up, okay? Someone, well, I guess not someone, but somebody messed up, okay? They, in one batch of this pill, they reverse the placebo with the actual pill. So you get 3 rows of placebo, 3 rows of drugs that does nothing, and 1 row of medicine, right? Think about how detrimental that must be, right? Like the person is relying this pill to avoid pregnancy, but then the pills were reversed. That means you're just taking candy every day, thinking it will, give you birth control, but then it didn't, right? So once that was discovered, they issue like an emergency statement. They're saying, okay, if you have been taking the pill, please use backup contraception, okay? Because the pills are literally not working, okay? Anyway, there is one question on this, about this on the quiz. So, maybe you want to watch that part of the recording again if you don't fully understand it. All right, moving on. Justin was saying earlier, right? Like people who are getting the placebo, they actually don't know about it, right? So that is called a blind experiment. In a blind experiment, the subjects, the people who are involved, does not know they are receiving the placebo. That's kind of the point. If you tell them you're receiving the placebo, then they are gonna that's not gonna be able to eliminate their bias, right? Okay, it's like you say you have a sleeping problem, and then I tell you, okay, eat the candy and you will sleep better, right? Then you'll be like, I'm not gonna believe it. Like, of course it's not gonna help me. It's just candy. But if I don't tell you it's candy, right? If I just tell you, take this, it's sleep medication. Maybe you will believe it and maybe you will end up sleeping better, right? So the whole point of eliminating psychological effect is not to let the subjects know. That's called a blind experiment, right? So like in this comic, you see the researcher will know whether they are giving the placebo or not, but the person receiving it does not know. The gold standard of experimentation involving, testing new drugs is a double-blind experiment. The person who's giving it does not know what they're giving, and the person receiving it also does not know what they're receiving, right? Sometimes there are conflicts of interest, right? Like if I work for a pharmaceutical company, I have an invested interest, a financial incentive to want the medication to work, right? So when I evaluate the results, maybe I am biased. Okay, so it's best not to know whether this person received it or not, right? And then I'll be able to evaluate the situation objectively. Yeah, so that's how it is with like vaccine and stuff, right? Like Pfizer, people who are working on the vaccine, they did not know which group is receiving the placebo or not, right? Some third party, some party that's overseeing the process that has no financial interest, right, in the situation. They are the ones who know who's receiving the placebo and who's not. Okay, so that's the difference between blind and double blind. All right, this next part is quite confusing for a lot of people. Let me try my best to explain to you. So we have a new drug here. I just made it up. It's called sleep, okay? And it's supposed to help reduce the symptoms of jet lag. For those people who don't know what jet lag is basically you know, when you fly to a different time zone and you can't really sleep properly, that's called jet lag. Yeah, you do feel horrible, you have headaches, you're like groggy all day, right? So, you know, there's this new pill called sleep, and it's supposed to help reduce the symptoms of jet lag. So, you know, to test this, we have 3 groups. We have the control group, which is the people with no treatment, not giving them anything, let them suffer. We have the placebo group, which is an inert substance. We give them candy. We don't tell them it's candy, okay? We just give them candy. You know, this is a pill, take it, it might help you. And then we have the treatment group, right? Which is the actual pill. Right? We don't tell them either. We just take it, it might help you, okay? And then you let people report to you, like, how was it, right? Like, did you experience more symptom, less symptoms, same symptoms, right? Okay, so we have a pretty big group here, 520 people. That's what this N means. N equals to 520. And in the control group, 70% of the people said they experienced symptoms of jet lag. Placebo, only 40%. Treatment group taking the actual pill, roughly, you know, 38%, 40% as well. So based on this result, do you think the new drug is effective in reducing the symptoms of jet lag? If you think the drug works, please choose A. If you think it does not work, please choose B. If you're not sure, you can choose C. Okay, works, not work, don't know. All right, anyone else? Last call before I close the poll. All right, so we have a pretty even split. 1/3 said it works, 1/3 said it doesn't work, the other 1/3 not quite sure. So let's take a look. All right, I want you to ignore this for a second. Just ignore this. Ignore the treatment group. Don't even look at it. Okay, cover your right eye or something. So control group, no treatment. You expect a lot of people have jet lag, right? Because they're not taking anything, right? They're not sleeping well. They have headaches or whatever, right? So not doing anything. Did you expect the placebo to work though? Like if you are the person who's conducting the experiment and you giving these people like candies, right? Basically placebo, sugar pill. Do you expect the sugar to work?
No.
No, right? Like it's just candy. It's not supposed to do anything. It's like that Band-Aid I gave my kid, right? Like it's not supposed to do anything, right? But you look at this and you know there is a reduction in jet lag symptoms. What does that tell you? Exactly. Some people say it's psychological, right? See, it's not the drug that's helping them. It's the fact that they feel like the drug is helping them, right? They're like, oh, I'm taking this thing. This is gonna help me. Okay, I'm gonna sleep better. And then they end up sleeping better. It's almost like, self-fulfilling prophecy, right? Okay. So based on that, right, it tells you it's like a psychological effect. And now let's take a look at the drug. When you give them the drug, I mean, it's not the same result, but it's a very similar result, right? So if both, right, listen to me carefully. If both placebo and treatment group produce the same result, they are both able to reduce the symptoms of jet lag, that tells you it's not the drug that's working. It's just the fact that they're taking something, anything that helps them sleep better, right? So in this case, the drug is not effective. Okay, I'll say that one more time. The drug is not effective because both the pill and the placebo were able to reduce the symptoms just as well. Okay. Any question before I move on?
So just to clarify that they're taking the placebo and the treatment group, that the fact that they're just taking something that they think will help is like,
Is an indication that the drug is not working, right? It's not the drug that's helping you to improve your symptoms, right? If it's only the drug that's doing it and not like the psychological effect, then the graph would look like this, right? Think about it. In this case, the placebo, which was not supposed to do anything, didn't really do anything, right? Like, I mean, you see a small reduction, but that could just be like sampling error, right? Okay, you see a small reduction, but for the most part, these are very similar, right? And that's what you would expect. You would expect the placebo to not work if it's actually like not psychological, right? And then only the drug was able to reduce it. Do you guys understand? So there is a private message. Could it be seen as they both are placebo? No, that's exactly it, right? Like in the previous example, like both of them are essentially behaving as a placebo, right? This medication or the drug, you could take either and it will make you feel better, right? Okay, so like in this case, it's both of them are just behaving as if they are the placebo, even though you're trying to see if the drug works or not, right? Okay. So like sometimes I was trying to say earlier, right? Sometimes you don't need to have a control group to compare it to. Okay, something like this, the psychological effect is gonna alter the result. But something like a vaccine, right? Something like a vaccine, you only need to have the control and the treatment group. Like you cannot have a psychological effect on whether you catch COVID or not, right? You can't just be like, yep, I'm gonna put this special sticker on myself and then I will not get COVID. Just because you think you're not gonna get it, it's not really gonna prevent it, right? It's very different compared to like jet lag, right? Compared to sleeping, right? Where in that case, the psychological effect actually is important. But for something like like a vaccine, you either will get the disease or you not get the disease, despite having a bias for it or not. So in that case, you will not need like placebo and control would be the same group in that situation. All right. Okay. I know we are kind of short in time, but I really wanted to do like a quick activity with you, okay? If you need to go, okay? It's okay, no hard feelings. I know you guys have another class later on and you might want to do something else in between the class. Give me a second, I'm trying to pull this thing up over here. How do I share this? Okay. I have a link. I'm gonna put it in the chat box. Okay, don't click on it just yet. I need to tell you what's going on. So let's take a look at this question. All right. A farmer wants to determine, this is in your study guide, a farmer wants to determine if feeding cows with high protein diet would increase milk yield. Okay, would increase milk yield or not. Why a hypothesis for this inquiry? We don't have time for that. I'll just tell you the hypothesis. The hypothesis is you either think it will increase the milk yield or you think it will not. Those are the only possible stands, right? Okay, so I can say feeding the cows with high protein diet will increase their milk yield. That's my hypothesis. Okay, so now let's jump to part C. Is a placebo needed in this experiment? What do you guys think? Just very quickly. Do you think you need a placebo for this? Okay.
No.
No? Okay, we have a lot of people who are saying no. Why not?
I feel like because they're cows, so like you don't really need to do that.
Yeah, exactly. Right. They're cows. They don't have a bias. Maybe they do, but we'll never know, right? The cow doesn't know they don't understand exactly. They're animals, right? They are not gonna know you're trying to, experiment on them. They're not gonna be like, oh, you know what? I'm gonna hold out on the milk because I know you're trying to, do something to me, right? Like there's no need for the placebo. Okay, placebo is just for psychological effects, right? So in this case, no need. But we do need to have a control group though, right? The control group would be the group that's receiving like regular protein diet, and then you're gonna have a group that's receiving like high protein diet, right? Okay. The independent variable is how much protein you feed them. The dependent variable, the one that you're observing, measuring, is how much milk they produce. All right. So what I want you to do for just like couple minutes is click on the link, and the link is kind of lost now because I asked a bunch of questions. There is the link. I want you to click on it and tell me 3 standardized variable in this experiment. Okay, we have 2 groups of cows receiving regular protein diet and cows receiving high protein diet, and we want to see how it affects their milk yield. What are some of the things that we must keep the same for the 2 groups of cows? Okay, click on the link, type in your answers, and then we will talk about it. I'll give you like, I don't know, like 2 minutes to try that, please. Your response are anonymous, so please do participate.
Sorry, what was the dependent variable?
The dependent variable is the one that you're observing and measuring. In this case, it would be the amount of milk, right? Like, is it going to make more milk, less milk, right? Okay, so let me just, for those of you who are not sure what to do, okay, so what you should be thinking about is 3 things we have to keep the same for the 2 groups of cows. Okay, so we have cows who are having regular diet, and then we have cows that are having high protein diet. Everything else needs to be the same, right? So what are some of the things that needs to be kept the same? That's what you have to tell me. Okay, 3 things. All right, so I have 10 responses already. 12 now. Okay, I'm just gonna wait a little bit longer. And again, if you need to go, that's okay. I know it's the end of class. I'm just gonna keep you for another 5 minutes if you don't mind. Okay, so maybe we'll come back here and take a look at what people have said. How do I show this? thing, it looks very small. I don't know, can you guys see? View results, of course. Sorry. There we go. Okay, so out of 15 responses, we have, let's see, same age of cows. Yeah, you don't want some old cows versus young cows, same age. Good. How much food? Yeah, and you want to feed them the same amount of food, but only the protein content is different. Now the diet might not be like correct, okay? Like it's not entirely correct because you are changing their diet, right? Okay, one has more protein than others, right? So like you want to be more specific in your description. You want them to be healthy, you want them to be in the same environment. You can't really control their sleep cycle, but like, I wouldn't be disturbing them. Like I wouldn't be like, poking at the cows when they're sleeping, but you just let them be in their natural environment, right? Like you can't really control that. The amount of milk is what you are measuring, right? That's the dependent variable, right? So you cannot standardize that. Do you understand? The dependent variable and the independent variables are the ones that you don't standardize. You're trying to assess them, right? Okay. Environment, very good, same place. So a lot of these are very similar. Housing. Gender. Okay, gender is another one. That's not that you're not gonna be standardizing, right? Why not? What kind of cows are we gonna be using? Are we using both like male and female cows? No, right? We only using female. Only female can produce milk, right? Okay, so like you're not gonna include male cow in this experiment, right? Therefore, gender is not a standardized variable in this case. Okay, everything else seems okay other than the ones that I talked about. Okay, so that's what you should study. Okay, like on the first quiz, there might be short answer questions. I might present you with a scenario, and then you will have to tell me what the standardized variables are. Is that okay? You can do more practice with the study guide. I only have a few more slides to go. It will only take me like 10 minutes at the beginning of next class. We will wrap that up next class, and we will begin lecture 2. So please print the stuff from lecture 2 for next week. Because we'll definitely start on that on Tuesday. But just one last thing before you go, one more poll questions, and then we'll be done. I promise you. You guys are so good. You guys are all staying here. No one's leaving. Thank you. So please try this. Okay, I am gonna stop the poll there. Let's take a look. 1 milliliter of an experimental drug diluted in a saline solution. Saline just means salt, okay? Solution is injected into 20 pregnant mice to determine possible side effects. Which of the following is a suitable control for the experiment? Because we are dealing with pregnant mice, anything that's male will automatically not be the correct choice. And again, we're dealing with pregnant mice, so we will not be using non-pregnant mice as a control. Okay, so that leaves two choices. Do we inject them with 2 milliliters of the drug or 1 milliliter of saline? Well, the answer should be obvious. It is E. Okay, you don't want to have two groups. One groups have drugs and then the other have more drugs. Then you have no baseline to compare it to, right? Remember, the control group is the group that you are not going to be, receiving any of the medication, right? So you would just be using the saline and not the drug. Okay, thank you once again for your attention and your participation. It was great. Enjoy the rest of your week, and I will see you first thing in the morning, 8:30 on Tuesday. Okay, feel free to email me if you need extra help or have any concerns. And the recordings will be up in a bit. All right, bye for now.